So how do you set this up? You know that the cross product of these two vectors is going to be, remember, I, j, k, 1 e to the t, e to the negative t, and 2 e to the t, negative e to the negative t. It's a lot of busy work, yes, I know. So it's the determinant of that matrix right there, or partial determinant. So the I entry is going to be what? Negative e to the... Really?
What?
You're multiplying these two right there. If you multiply those two, you add the powers. So what does it become? Negative e to the 0 minus e to the what? 0 minus j times negative e to the negative t minus 2e to the negative t plus k times e to the t minus 2e to the t. So what do you end up with? I times negative 1 minus 1 minus j times, what do you end up with there? 3e to the negative t plus k times negative e to the t. At least they're like terms. That's nice. So what do you get? Negative 2i plus 3e to the negative tj plus, or minus what? Minus k e to the t. So if you wanted to write it in component form, you could say negative 2 3e to the negative t comma negative k. Oh, that's... Oh, I'm not... the k's that should go at the end, sorry. Negative e to the t. So there's your cross product right there. And what does it also ask you to do in this question? Prove that they're orthogonal. How do you prove the two vectors are orthogonal? The dot product better be? So what was the first vector? Let's just do it with a here. 1, what was a equal to? 1 e to the t comma what? E to the negative t. So you do a dot a cross b. That's going to be 1 comma e to the t comma e to the negative t dot this product that we just found out, 2 3e to the negative t negative e to the t. Where did I miss? Oh, negative. Before the 2, thank you. Thank you. So then you just, what do you end up? You just dot product is pair and add, right? So what do you get? 2 plus 3, negative 2 plus what? 3, but you're multiplying them together, right? 3e to the what power? 0 minus e to the 0. So you end up with negative 2 plus 3 minus 1. What's that? 0. So therefore they have to be orthogonal. I'm not going to do the other one, but it is. Are we okay with that one? Yeah, you want AB cross AC. I, J, K. And what are the three vectors? 0, oh no, not 0, 1, 4. What are they? Negative 2, negative 2, 3, and negative 5, negative 3, 1.
It shouldn't matter which order you put the vectors in. So
there's going to be many different, yeah, it should not order, because you might get a different direction. Yeah, they just should be scalar multiples of each other. If two vectors are parallel, they're going to be scalar multiples of one another. So let's see what we get, and we'll compare it to your numeric value, okay? So what do you end up with? I times negative 2 minus negative 9. Oh, not plus j, minus j times what? Negative 2 minus negative 15 plus k times 6 minus 10, I think it is. Is that correct?
Yes.
Thanks. So what do you end up with? 7i plus what? 13j minus 4k. Minus 13j, thank you. So we end up with a vector 7, 13, 4. What did you get, Solnit?
negative 8, negative 5, negative 8.
What is 7, negative 13, negative 4?
7, negative 13, negative 4. Thank you. I love the chorus on that response there. I'll check your work in a sec. We might have done something wrong. I don't know. Let's just go with this for now, okay? Does that make sense, everybody?
We should get the same
Yeah.
magnitudes, too.
So we cross those two, A, B, A, B, C. So that gives you the answer to the first part of this. And it says find the area of the triangle formed by those three. How do you find the area? The magnitude of that vector. We want the magnitude of this. But I wanted the area of the triangle, correct? Not the parallelogram. So what am I going to have to do? Because this is the parallelogram right there. Divide by 2, exactly. It's just half. So what do you end up with? 1/2 times the square root of what? Times what?
7 squared.
49 plus, plus. So you end up with 1/2 times the square root of what? 79, 85, 225, 234. Did I get that right? Please correct me if it's wrong. Doing it quick.